Hi, my name's Ramana Radhakrishnan. I'm the tech lead for the GNU toolchain in ARM. I look after the A profile, which is essentially the GNU toolchain for the parts that go into Linux or that run Linux most of the time. Damn, I had too much food last night. And I'm here to talk about what we're doing for the ARM and AArch64 ports today. So just before we start, I've heard a lot about this during the conference, and all I want to say is that. So it's business as usual for us. There's nothing to say here, so let's move on. And after that commercial, let's get down to business. So what are we doing this year? Bin and a couple of others have been looking at trying to improve IV ops and make a few changes in the vectorizer to sort of clean up where we are peeling too much and things like that. Bin understands a lot more about it, so you can talk to him or follow his patches as they appear. The other big thing we're doing this year is store widening, which is a patch that Kirill's been pushing for a couple of months now. I think it's going through final iterations, so hopefully that will make a good impact in terms of what we're doing. The last time I saw his numbers, it seemed like we're getting good benefits out of that. In terms of architectural support for this year, we've got 8.2a finishing up. James has been fighting with float 16. So we're doing the float 16 part. The PowerPC guys can worry about underscore float 128. So that's where we are. We've also got a number of things for the microcontroller side. We've got V8M coming in and all the architecture extensions for that. So that's going into GCC, probably for GCC 7. The other big thing, which I don't have much detail on today, is the work that a number of colleagues are working on is on the scalable vector extensions. This is a new vector unit that's being proposed as an optional feature in ARM v8. This is AArch64 only, and the idea is that there is no fixed vector length. There's no hard-coded vector length anymore in the architecture. And there'll be some amount of tail end of memory models work, and there's just a host of other small little performance changes that we will do as we go along for the rest of the year. So that's what's happening. In terms of what's gone into the source base already and what I've just sort of seen from the lists has been, there's been a lot of tuning going in for a number of parts. These are parts that are made by our architectural partners. So for example, I know that Andrew's been pushing some ThunderX patches. Jim's been pushing some QDF, the Qualcomm part patches. And Ivandro has been pushing patches for Samsung's Exynos M1 part. There's been a number of optimizations around the way in which we generate square root and so on. James has pushed a number of changes for if conversion, which was more to do with, I think it was some kind of debt in terms of fixing the cost model for RTL if conversion and fixing that up, so that's gone in. We've had to do some changes for VecCond and VCond mask, even though Advanced SIMD for AArch64 or ARM doesn't have the mask registers or the predicate registers. We've had to use that to get better vectorization. It's knocked off a couple of instructions in H.264, if I remember correctly, in Spec 2006. That was something that Bin did recently, and I think it fixed one particular bug in Bugzilla. The other main thing is SVE support is now in binutils. We should start getting the patches for GCC I can't give an exact timeline. It's sort of end of this month, maybe next month, don't know. We'll probably start seeing some of the patches for SVE in GCC as well. It's support for the vectorizer and the backend. There may be some changes coming to the vectorizer as well. Well, it will probably come with, it would be discussed appropriately. And the other one would be, that's going on right now, is work for Go split stacks. So I had the following topics for discussion. It was more around deleting pre-ARM v4 support. We deprecated pre-ARM v4 support in GCC 6. We'd like to get rid of it in GCC 7. Are there any objections in the room? Oh, thank you. There was probably not a very serious objection over there, just for the record. The other topic was about ILP32, and if there was anything that needed to be discussed about it. I know patches for AArch64 ILP32 are on glibc and the kernel. The main discussion points are just about getting the kernel ABI right. And
do they have any discussions on those? Otherwise, come talk to me later or whatever.
No.
Well, I mean, you can email me too, so it's not, I won't bite you guys.
Okay, if you want to ask anything about ILP32, talk to Ann Rupinski. On the record, so. We have had quite a lot of angst with respect to the command line options for AArch32. The amount of variance we have, so we've got a proposal and we've got something we'd like to discuss in that area. Before we get to that, are there any topics that people in the room want to bring up with respect to the ARM or AArch64 port?
There was a big and little endian support, and one part had working vectorizer, not working vectorizer, and stuff like that.
So the question was about big endian versus little endian and the fun we have with the vectorizer for big endian. I mean, little endian, there's no problem. It all works. It's fine.
It's the correct endian.
It works. There's no. I'll be careful about passing judgment there, but it's. So as far as I know, AArch64 big endian works reasonably well with the vectorizer. I believe we fixed up the various things in the back end to make that work. On ARM with big endian and vectorization in the AArch32 port, there are still issues.
Actually, will challenge big endian as well, because fundamentally
the endian is defined for variable size thing.
that's the problem, right?
It's just memory order.
Yeah. But at present, the compiler has got a fairly inbuilt assumption that in big endian, the vector is loaded in sort of a non-byte swapping form.
Yeah. So the status as I know it is on AArch64 big endian with advanced SIMD. I won't come to SVE because I don't know anything about it. So let's leave it for the minute. In advanced SIMD big endian, I believe it works, and I'm looking at James trying to see if he has anything to add over there.
Yeah, it passes the test suite, intrinsic test suites, but at some point, Yeah, yeah. We don't have extensive testing of big endian, only running the test suite each night. So it's hard to say that it works, but it
Be enough testing coverage, I guess.
plenty of corner cases in the vectorizer for big endian. I don't know whether we caught all of them.
Well, the vectorizer now has no longer any endianness dependence thanks to Alan, I think, who removed all of them and pushed the bottom on the back end.
So, as far as I know, what we did was to fix the back end with respect to what needed to be done for big endian on AArch64. We didn't disable a lot of things, I don't think. Yeah, to start out with we did, but there was a push to sort of clean it up and fix it in the 4.9 time frame, if I remember correctly. On ARM with big endian and neon, we haven't yet really put in that effort because I'm not sure who's asking for it.
I mean, I don't want to say it's perfect because
I've heard a couple of customers asking for it.
Network side is
I think the last release, the narrow fix, a couple of issues with vectorizer.
Yeah. Maybe one thought is just to disable big endian and vectorizer on neon, but I'm not.
From the PowerPC side, we found problems when we added an option that says it's little endian, but when it's in the vector, the indexes are big endian, because the hardware is essentially still big endian, and you don't the opposite problem, and that just adds a lot of complication, and it's better to just say, deal with it.
Yeah.
We work through most of that. We don't do any endian switching. We just every now and then get a whiteboard out and talk exactly what GCC thinks of vectors and what we think of vectors. Hang together, but then someone added some extra foldings to RTL last week. We found another pattern really got it wrong. So we do vec combined, two back to back. You want zeros in the upper bits of the register. And you have to have a big endian pattern that puts the zeros first for the vec combine, and a little endian pattern that puts the vector first and then the zeros. Yeah.
So actually there possibly is a problem there, that there are some things where it's very hard to express them in machine descriptions. The RTL that is currently generated, particularly when you get subregs, where subregs in big endian and little endian, they've got the wrong index, and you can't turn that into a sane pattern matching rule. So if anybody can think of a good way of doing that without using match operator, which is not ideal in this case, that would be an interesting experiment to go look at.
Richard, yeah, I've come to the conclusion subregs are just evil for vector stuff, and
I wasn't talking specifically vectors either. I mean, yes, vectors it's probably even worse, but
vectors probably one vec select instead. But my way, it's not, it's approved or whatever, is to keep the thing until reload as a whole unit, and then do splits afterwards, where you then can expose individual registers or whatever, rather than trying to deal with subregs before register allocation.
Okay. Any other topics?
So but this is more of a technical thing, but
We're supposed to be discussing technicals.
yeah, I know. Well, no, I mean, this is, one thing is the vector cost model needs to be, I don't know, I have to figure out if it's a problem in just the AArch64 backend, or there's multiple stuff that needs to be done outside of it, but the cost model is not very, how do I explain this? Very verbose enough for what I've seen so far.
I think what you're trying to say is slides are more Well, yeah, that sort of idea, right?
Well, no,
Scalar
I'm saying-
statements in
well,
ARch64
so-
backend are all cost 1.
Well, that's just linear.
Yeah.
So the vector cost model in the ARch64 backend is rather simplistic at the minute. I think it's just hard-coded costs and numbers at the minute. It's not. It doesn't really follow the same kind of model that the PowerPC guys do with respect to looking at the new interface, which is the thing which tells you about the prologue, body, and the epilogue.
One. Sorry. Okay. I don't think PowerPC does a lot more than other targets like x86 or ARC64. The prologue and epilogue are just initialized to 0. What PowerPC does is based on estimation, it will add an additional cost to the overall vector cost by analyzing the density in the vectorized loop. That's all I think. Yeah. The default yes, that's a target dependent. That's a target dependent cost computation for each target. But the prologue and epilogue are all initialized to 0 for ARC64 and x86 or ARC64. Yeah. We may have cases that we may have similar cases to PowerPC that for some vectorized loop, there are too many vectorized instructions that stores a pipeline for vectorizer unit, but we don't have a clear case example for that. But I might do some experiment tuning that estimated cost to see if it impacts on some benchmarks. But yeah.
If we want this, we should implement it.
Yeah.
Okay.
That's what I'm saying.
Yeah.
So one thing I know is that we know, sorry, yeah. So one thing I know, right now, we don't do any mode-based ones. We just say it's all the same cost for integer and floating point. But for Thunder, the difference between the integer and the integer vector is different. That the this multiplier is different between those versus the floating point side, which is the same. You know, they're actually the same cost. For the scalar and the vector, it's the same cost. So that's another example. So, but that's easy. That part's easy.
So just a few comments. So we do have this new fancy cost model entry where you in theory can inspect a lot of vectorizer internal data and the statement and do something fancy. But on the other hand, the vectorizer compares against a very simplistic estimate of the scalar cost of the loop. So getting too fancy without getting also fancy on computing the scalar cost side is probably not going to be a win in the end. So and the new fancy interface may also be not the best one. So I'm not actively encouraging people to invest too much engineering effort in exploiting that.
It's certainly worth an investigation. Is it still worth an investigation or? Yeah, okay. Yeah, that's I think where we are at the minute. So, okay. right. How much time do we have left? Plenty, okay. Well, then the other topic is a recipe for a bike shed. So if there are other topics that we want to discuss, I think we should try and get it in before that.
I do have some IRP32 related questions. So, okay, so one is, do distribution care, or how much they care, or about IRP32 on AR64? Do they plan to package it or something? And how much performance regression do we accept on LP64 because of IRP32?
So I can at least, so depending on so I can answer the regression part. So it's the kernel side that's usually the regression, not the GCC at all, code gen, because that will never regress.
Actually, no, that in some cases your stack grows. In many cases we see, particularly in spec int, the stack grows because pointers now are bigger, stack frames are bigger, and so forth. So decache then becomes less. Oh, you meant on the compiler. You meant on the compiler itself. I thought you meant on the runtime. The effect of running 32-bit programs compared to 64-bit programs.
We're talking about actual runtime of current applications, and such, not the differences between ILP32 and LP64. So we're talking about regressions of the current applications, current system versus next system, same thing, but the difference is there. So glibc, there shouldn't be any difference even there. It's more the kernel side that's going to be where the syscalls, there shouldn't be that big of a regression in LP64, but there is extra instructions and for every system call to check to see if you're an ILP32 application or not. And those are it's about one load and one branch. And one branch compare. For the overhead for LP64. Now, for ILP32 versus previous ILP32 versus current one, that's where the regression comes in, because the ABI change, the multiple ABI changes that are happening is causing regressions because they are requesting the ABI changes to make stuff simpler but slower in some cases.
So you're only having a 64-bit kernel and not a 32-bit kernel? Okay. Well, there was for ARM 32.
It's the same thing with MIPS 64. There is no N32.
So basically, your question is then, would distros enable the multi-libbing, and not if they ship a pure 32-bit system?
Which means regressions.
So the load. Well, so the other thing is, the one other thing to note about where the load happens is the load will happen from that page anyways, or from that cache line anyways, because there are other. No. So that regression all has to do with ILP32 old versus ILP32 new. Yeah, but that's because it didn't describe right.
The way it was described was LP64 had a regression.
Right. It will have a small regression.
and the numbers seem to be with respect to that rather than just the previous ILP32 versus the new
Okay.
IA.
I don't know. So it will have a small regression because no up system call now has an extra load and an extra branch.
Okay.
So there will be a small regression, yes, for no up system calls. Or for any system call. What? That's what I'm trying to say, is the system calls will have a slight regression, yes. But
Okay.
it's, the overhead is, he's going to be small. So for a no up one, there's going to be large, it's going to be large because,
Mm.
you have the percentage, of the executed. Well, no, but the point is with the no up system call, your overhead is just about doing the
System call, yeah.
And if you have a regular system call, well, there's going to be a lot more overhead past that.
So that will just hide. It's not going to appear in a regular system call anyway.
Correct.
Which, yeah, okay.
And we cache like get PID anyways in glibc. And so there's other system calls that we already caching anyways. So like get PID, I know we cache in glibc as of right now anyways. So you won't see that regression really. There are other ones like get time of day. You won't see it because the VHSL. Yeah, so you won't see like get time of day. There's a bunch of other ones that you might see. Futex, you might see in Futex, but you probably won't because the rest of the system call itself is pretty expensive anyways.
Okay. Maybe a clarification to the glibc list would be good in
Yeah.
terms of what those numbers actually mean.
Yeah. Totally agree. I'll have to look into the numbers. I didn't really look exactly into the numbers, but yeah, I'll make sure that gets clarified.
Okay. I suppose we have about 20 minutes left or half an hour. So let's go to the whole thing about AArch32 FPU command line confusion. The way in which the ARM backend is structured is that you've got different architecture levels which control the integer instruction set, for want of a better word, which is controlled by the march option. You have a separate command line option for mfpu, which again has its own set of options. I've lost count as to how many options there are. And users are free to choose any combination of the two, even if that wouldn't make sense. So for example, mfpu equal to vfp actually means vfp v2, which came around the ARM v5 time frame, if I remember correctly. ARM v5t, I think, around that time frame. And mfpu equal to neon implies the VFP plus neon SIMD unit as it existed in the Cortex A8, which came out in 2007, something like that, probably earlier than that. When you use this, when you use these options with the ARM VA on the ARM v8a cores using the march options, you essentially drop a lot of functionality on the floor. You've got instructions for fuse, multiply, accumulate. You've got instructions for rounding and other operations that there's round, seal, and a bunch of other operations that you essentially drop on the floor. So what I'm trying to say is mCPU equal to Cortex A53, which is a ARM v8a core. mFPU equal to neon is not the same as mFPU equal to neon FP ARM v8. They will enable different behavior in the compiler. So the proposal really is that we reduce the amount of orthogonal variation in the options. In essence, try and effectively make the MFPU option derive the FPU architecture from the main architecture or the main CPU part, rather than allowing someone to create a space and a mythical part. Yeah, a Franken implementation. This has
whatever on with MArch that are not existing. Obviously, it will always be possible.
Obviously, unlike ARM, the users are not using that option. So misguided.
yeah, but that you can't do native on a cross build, and we have users who use it cross as well. So we've got to find something that suits both type of users, especially in the ARM backend. This is what we're
It takes it from the architecture specification. What I'm looking for, sorry, take that. What I'm looking for is when I've got an architecture equals V8A, all I say is, and I've got the FP unit, and it knows that the FP unit that came with V8A is a particular class of specification, at least to a baseline. At present, if I say FPU equals FP, it just says, oh, I don't know what FPU mean. Well, it does. It says I'm going to assume that you've got the most basic FP unit that was ever done on the device, which is clearly nonsensical. Is it on the other side, Ramana? Yeah, essentially we've got two ways forward. We could either keep the FPU option as a separate option, and perhaps have three variants of it. So you've got FP equals FP, Neon, Crypto, because Crypto is an extension on Neon. Or we could get rid of it entirely and essentially deprecate FPU and move everything into the architecture tags, so that you pick it all up through -M CPU or -M Arch. It does mean if I do it through the architecture tag and I have CPUs, I now have to have CPU descriptions which have no FPU or no Neon and so on. It means I create a larger table of CPU names. In fact, that's what the commercial ARM compilers all do. They don't have this separate FPU type concept. So I can either do it through the FPU option directly and have those options, or I could just move it all into the Arch flag. Seems to make sense to me to move it all into the Arch flag and start the procedure of deprecating FPU entirely. If I leave the FPU flag in there and have this auto option, I do have the option now that the users can still specify an explicit FPU variant, and they will get essentially the same behavior as they had before.
If they want.
Sorry? If they really want to, but I mean...
Perhaps in addition to the MFPU auto, you could add a compile configuration flag which tells that MFPU auto is the default.
Absolutely, yes. I mean, and that's what I would make the default in the configure if they don't say with FPU. We would have to train users to stop using with FPU, and perhaps even deprecate that option, change it to something else long term. But there are a number of things, and I don't think this is something that's going to happen entirely overnight. You know, we can't just completely break everybody's build scripts. So we would have to continue supporting it.
I'm trying to find the best way forward that allows us to support a new simplified interface without breaking all the legacy variants that might exist. But it seems silly to me that we allow these Franken architectures in rather silly ways, and in particular users to just trip themselves up. The main problem is that we didn't put version numbers against the early versions, and so users think, oh, I've told you you've got Neon, why aren't you, and then they ask, why aren't you using Neon to the full? And the answer is actually the command option you gave wasn't the one that you really intended to.
And it's also about the reproducing the bugs in the ARM backend. The number of, I know you.
Process. What? I configured this. I have to change triplets slightly. FPU, what do I need? And usually the information is missing from the bug because people don't attach the -v out.
Well, if it was in the configure, they probably don't even realize it.
So it's a constant angst for everybody who's triaging bugs. I know you've gone through the pain. I go through the pain. Everyone goes through that pain. Everyone who looks at Bugzilla goes through that pain. So can we do something to simplify this?
I'd point out here.
Can't control that. Sorry.
I point out here the ARch64 compiler doesn't have this problem because we don't have a -m FPU option there at all. It's only configured through the Arch flag, and I think actually in retrospect that was the right decision. And I'd now like to try and find a way of getting the ARM port into a similar position.
There's even one more layer on top of that, is that you can't even specify like the statistical profiling without ARMv8 8.2 even now, for an example. The only one that's the exception is the LSE. All the other ones you actually have to specify the architecture as the base architecture first of the lowest one that was existing in that.
Yeah, I mean I agree, and I think actually we should try and make it as hard as possible to generate code that is not to an official architecture variant. There should be some way, but it shouldn't be that intuitive. The intuitive thing should give you the right answer for the most cases. Yes, when you're doing native, of course. No, not at all at present.
Because ARch equal to native essentially only detects the integer architecture.
There isn't a -m FPU because native.
And on ARch64 there's no problem again because ARch equal to native essentially would detect the FPU as well. The FPU is implied by the base architecture level that it detects, so you're fine there. There is no MFPU option. There is no MFPU option. The only way in ARch64 that you can prevent generation of FP instructions is by using mgeneral regis, and that's needed specifically for the kernel because they don't want to trample on the FP registers. Otherwise, there's no orthogonality there. So
That's because we've only got a hard float ABI in ARch64. We don't support a soft float ABI, and therefore, if you want to build code that doesn't use the floating point registers, you better make sure you haven't got any floating point, in particular parameters, but any floating point data operations either. Yeah.
yeah, and we tightened it in that regard.
I mean, technically, floating point is an option in ARch64, but GCC doesn't support it. And while I have any real say in it, I'd like it to remain that way.
I agree. But I've heard of one I have heard of one Monta Vista customer that actually wants it that way. It wants it the opposite. I don't know why, but they do.
We
Just saying, they did.
we hear mutterings occasionally, but so far we've managed to just about hold the line. And
As I said,
certainly in terms of Linux variants, I would be very, very much opposed to making it too easy to get different ABI variants in this area. We've already got big endian and little endian, a whole load of different memory models, and the ILP32 to deal with. It's more than enough variations in there. Yeah, memory models we can sort of deal with. We can have multiple memory models within the same ABI.
Well, yeah, we are already at 4 ABIs if you have big endian, little endian, ILP32. So, yeah, we don't want more if we can avoid it. Any thoughts?
Any alternative suggestions?
Just supporting your idea.
right, good. Seems like a good idea to me.
It'll be pink then.
Well, pink died actually. Not the. Never mind. I'm talking about the OS.
Yeah.
Okay, if we've got no other topics, then maybe we should stop here and have an early break.
I'm working on the simplifying the control flow graph for vectorized loop, and just sent the patch before this Cauldron. And for currently the control flow graph is kind of complicated because it adds guard and branch at before prelog and vectorized loop, and it also adds guard and branch after prelog and vectorized loop. So I tried to simplify that, and given if Richie approves that, review that patch. Yes, but the major one is left for you, I think. And the question I want to ask is actually the simplified control flow graph is exactly the same for the loop unrolling. So I might want to reuse that part for the loop unroller for tree level. Somehow, for example, I might start conservatively by only unroll the not vectorized loop after vectorization. I think that might be benefit the at least small benchmarks, I think. So yeah.
Or for CSE or for something else. So whatever this is what you want to enable should perform the unrolling. We shouldn't just unroll because we can unroll, because it just will increase code size. It will make some CPU's loop detection no longer work because the loop gets too big. I don't know if ARM cores have something like a loop cache or something like that. And I think that the Intel one covers 3 cache lines or something. So that's usually pretty small. So it just unrolling a loop because you can is usually a bad idea. So if you do some stuff like SMS, we do that on RTL. SMS sounds like it could be done on Gimpel as well. So you can do the SMS and the unrolling on Gimpel, where we even have the better dependence information to schedule your loads and stores. So just use it only as an enabler.
So it's certainly true we don't want to do arbitrary unrolling, and probably and in particular we don't want to do it on large loops, and we probably don't want to do it 4 times in many cases. or 8 times. Yeah. I think experimentation shows that for small loops in general, unrolling twice is a win because you're getting rid of a lot more branches that way. As long as you know that it's got a factor of 2. That's why I said for small loops. Now, definition of small, of course, is somewhat variable, and it's certainly a back-end question that needs to be answered. Essentially, how many isn's, and that's another problem, of course, estimating the number of isn's early enough for the unroller is somewhat arbitrary versus what you're going to get in terms of real instructions in the final code. It's even harder in Thumb because it may not be number of instructions as number of bytes. And that's going to be true also for other variable length instruction architectures. Who cares about them?
No, I'm saying that in terms of there's only 2 really ones that matter right now.
Yeah, but power is not arbitrary length.
Yeah, that's what I said.
Yeah.
Nobody cares about microloops.
Any other questions?
Sorry. There has been some complaints, bug reports by some users that building ARM GCC now takes up all of their memory because they're building it on their Raspberry Pis or something like that. That's because our automata keep growing. It's like, I think someone suggests something maybe for those users to like create a way for people to configure GCC to support only one particular CPU they're going to use on their board. Presume that would require a lot of surgery and like automata, the AMD automata stuff. But as a blue sky idea, would people think that's feasible?
The gen automata
Yeah.
the memory or compiling the generated automata?
I think gen automata itself. Because as people keep adding more pipeline description, it keeps growing.
Just because we have a lot of states in the generated automata.
Yeah.
I think that's the problem here.
No, it's the gen problem.
No, it's gen automata.
Gen.
It's gen automata itself. I mean, there are ways to reduce it because sometimes some process descriptions are written in such a way that they just unnecessarily reserve too many reservation states, and like reducing them usually brings down the memory usage. But people keep adding new processors, so we keep adding more states.
So the instant automata could be just generated at distribution time. It will blow up firewalls quite a bit, but maybe they could consider.
Oh, the other possibility is just put in a hard limit. So if you see a number of states in a particular thing, you just chop that in gen automata, so you don't generate all those states. And the user describes the thing, but frankly, if you've got more than about 8 slots in a particular automata, let's say 10 or 15 as an absolute limit, you're probably going to never find a schedule that can exploit all those extra slots anyway.
Do you right now generate a SIMA function which handles all the CPUs?
For a particular architecture, yes. Yeah.
But that's not,
Perhaps we
it's not, that's
think
not
about generating
no.
separate-
No,
it's not the problem to compile instant automata. The problem is generating it. So that doesn't matter if it's a single function. Instant automata is basically just a large number of tables, not functions.
Yes, so you would choose to generate automata for this and this ISA or whatever.
Well, this is the CPU essentially. So if you're running your Raspberry Pi, you're only ever going to use the compiler build for your Raspberry Pi. You don't care about all the different. Well, you might not care about all the different server CPUs that you have scheduled models for example.
I don't think that's actually the problem. I think the problem is the depth of the reservations.
Yeah, but if you have separate sets of each processor type has a different set of reservation and so on, and they don't share too much, then you could split it into.
I think it already does. I think it already does that to a large extent. We can add as many automata as we like, and each new one creates its own table. Well, it doesn't if you don't need that one. Yeah. Yeah. Yeah.
Single process that generates all of them. And so perhaps we could, in the makefile, run the generator several times.
It's about doing that on a Raspberry Pi. It's a multi-threading.
Buy a bigger Raspberry Pi.
In the when we were adding Power 9, we came into the same situation. We've done the workarounds, and of course we have much more memory, so it's not the Raspberry Pi situation, but it still is a lurking problem.
It is a build time problem because the simplification of those general automata states does take time.
And this is one of the things which doesn't scale. Like if you have nice landing with 244 or how many threads, and this is a single point of.
Yeah, I mean you'll see very often you'll see this is the last compilation step to finish in a single build or a single pass of the compiler building. Yeah, and it's running that. Sorry. Oh well.
I mean, you should fix your meshing descriptions to not be as deep.
Well, we do try to, but other people keep committing them without spotting it, and the first we notice is the whinges on the yeah.
Maybe an option.
Yeah.
Maybe an option. Maybe an option is add a thing which you can make it warrant after a specific limit. Well, no. I mean, so if somebody accidentally puts it in, there's a warning.
Yeah.
Or
So.
it has the stats annotation that just dumps you a table.
Well, no,
But
it's
you can
there.
get it to a warrant. Yeah.
The dumping of the table is there. It's just that it's disabled usually. So.
I think it's something we can collectively find a solution for, even if it is just sort of hard limiting these things to something that's actually sane.
Well, maybe the first thing we can do is look at all these large states, these large latencies, and chop them down in the first place.
I mean, we do the run.
older CPUs just start with the tables.
I don't think the pre-ARM v4 doesn't have that many large
I think
states.
there's one automata that gets removed for the pre-4.
FA526.
But I don't think it's the 6 states.
Yeah, I don't think we have a rotor automata for strong arm. Oh, it's probably in the generic
It's
automata.
just a generic
Yeah.
automata. Yeah.
We should probably kill anyway because it's probably so inaccurate as to be useless.
The general approach is actually to use more automata. When you use more automata, it's the overall size is smaller actually. It's a splitting, or you can use actually one automata for all processors. Then it will be very, very huge. But it's not necessary to use one automata for one processor. You could use more than one automata for one processor.
Yeah, we do that for some of them. For example, split the integer part and the FP simply part of separate automata. It helps some of them.
Yeah, I will look at this. Simply, I didn't touch this code probably for 10 years. And nobody touched this. It worked until now.
It still works.
I see.
It's just reaching the scalability issues.
Actually, perhaps there's an idea there that we should actually document putting the things like the floating point and square root in their own automata as being standard practice.
I think we say long latency. Documentation already says that long latency things should be split out into separate automata.
Right.
I think it does.
Does it say that?
Yeah, I think it does because it has some words about the size of the automata. I haven't written a scheduling description in many years now, but the last time I looked, I think there was some documentation on this. But if it isn't, we can fix it. Yeah.
ThunderX is a good model of how to do it right in the ARC.
You know where I
Or,
copied
sorry,
it?
no, how to do it small in the ARC.
So-
ThunderX one is on the order of 100 states, whereas the others are on the order of 50,000.
The funny thing there is I copied it from the Octeon one basically. So yeah, I basically modeled off the Octeon one, which I didn't write. So
I don't know how well it describes the processor.
that's that.
But
I'm
it's
just
nice
saying.
and small.
Yeah.
Oh, completely out of order.
That's from ThunderX, which actually is a good model for.
One of our older CPUs, I used to joke that the only thing that was out of order about that core was the claim that it was out of order. I think we're done.
I think we're done. Cool. Thanks.
Thank you.